All right, this is 4.6 part B, video number 3. We'll do the last 3 problems here. So we're going to graph our function, which is 1/2 cotangent of x minus pi. Let's just do our usual amplitude. Our amplitude here is going to be 1/2. Our period, again, period is pi over b when we're dealing with tangent, cotangent. And in this case, b is 1, so this is just pi. And our midline, again, is y equals 0, because there is no plus or minus d. So our end points, well, we basically are shifting we're shifting right pi. So instead of, this is cotangent, so cotangents endpoints typically are 0 and pi. So if we shift over pi, then it's going to be pi and 2 pi. And we'll look at this in a minute, because basically it's the same graph as if we didn't have this. If you shift over an entire period, then basically you just have the same graph. And then the last thing is our key points. And that's just going to be our usual pi over 4, right? Our period divided by 4. All right, so let's graph this. So our endpoints are where our asymptotes are going to be. And so this is going to be at pi and at 2 pi. Okay. We go to the point, oh boy. So we look at the point directly in between the two asymptotes, and it's on our midline. So this would be that middle point. And then this is cotangent. Again, you could draw, I haven't been doing tables, because I'm just going based on, simple. I mean, if we wanted to draw a table like we did on the parent function, we could, but we know cotangent goes from upper left to lower right. So we go in between one asymptote in the middle, and we go up whatever our amplitude is. In this case, our amplitude is 1/2. I'll go ahead and scale this. I didn't scale it before. We'll scale this as 1, 2, -1, -2. That way, when I draw this, I can use this point here. That's 1/2. And then this is going to be -1/2. All right, and then we draw this in. Oops. Okay. And to the point I was making, if we were so that's the period that we're given based on that equation, that one period. But if we were to draw this out, then it would be, this is where it would normally be if we didn't have this shift here. If we just had 1/2 cotangent x, then it would be what I'm drawing right now, right? Which is still part of the solution to this. So these are basically the exact same function, all right? Because when you draw them out, it's just going to keep going. Same period. Yeah, the only thing is our amplitude is 1/2, but as far as the positioning, that's all the same. Okay. Number 5. Okay. Amplitudes, do our usual. Amplitude, again, amplitude is the absolute value of A. So in this case, it's going to be the absolute value of -4, which means it's 4 is our amplitude. Our period, let's look at this, how this is another way to rewrite this. This would be -4 tangent of 1/3 x. So indeed, I have a b. So if my period is pi over b, b in this case is 1/3. So this is going to be pi divided by 1/3, which equals 3 pi. So there's my period. There's my amplitude. Okay, my midline is the usual, y equals 0. My endpoints, well, my endpoints are just going to be, well, let's see, no, we're tangent. Okay, tangent, tangent, tangent. So normally our endpoints would be negative pi over 2. Well, let me do it this way. Let's go back. We can do a couple different ways. So we can go back here, right? Set that equal to 1/3 x equals negative pi over 2. So x equals negative 3 pi over 2. And then 1/3 x equals positive pi over 2. So x equals 3 pi over 2. That's one way to get them. The other way is to think about it. Okay, we have our endpoints are negative pi over 2 and pi over 2. Those are our traditional endpoints. But then we just multiply. Since our period is 3 pi, we just basically multiply everything by 3. So different ways of looking at it. But the endpoints are negative 3 pi over 2 and negative 3 pi. Oops, not negative, positive 3 pi over 2. They're my endpoints. And then key points, sorry, I'm at my mom and aunt's house. And okay. In this case, we're going to just take our 3 pi, which is our period, and divide it by 4. Okay, let's graph it. Endpoints, that's where our asymptotes are going to go. So negative 3 pi over 2 and 3 pi over 2. Massive. Okay. Because our period is 3 pi, right? So let's see. That's 1 pi. That's 2 pi. And that's 3 pi. Okay. So that's our 3 pi period. All right, the point in between the two asymptotes is right here. We talked about our key points. So it's every 3. This would be 3 pi over 4, 3 pi over 4, 3 pi over 4, 3 pi over 4. This middle one, that's on our midline. This is tangent. Oh, but was it a negative? Yeah. We have this, which means we're going to reflect. So where we would normally have gone up here, let's do this. 1, 2, 3, 4, 4, negative 4. So tangent, where we would normally go up here, okay, because of that negative, we've reflected it. So indeed, it's going to be over here, not here. And then we'll come down here. And of course, doesn't fit on the grid. You get the idea. Okay, so, excuse me, our amplitude, that's our amplitude. This is our amplitude, okay. These are our key points, that 3 pi over 4. And then this is our period. Oh no, that's not our period. The whole thing here to here is our period. From here to here, that's our period. Okay, I don't know why I draw all that stuff in there. Okay, that's what it should look like. Last one. What all things do we have here? Well, amplitude is 2. Period is pi. Midline. Did we not have any midline changes here? No, we didn't. That's really too bad. Oh well. That kind of stinks. Okay, midline is y equals 0, so our graph never changed anyway. our endpoints. Okay, this is cotangent. And cotangent normally goes 0 to pi. We're shifting left pi over 2. So instead of 0, it's going to be negative pi over 2. And instead of pi, it's going to be pi over 2. Again, if you want to do it mathematically, you go x plus pi over 2 equals 0. So x equals negative pi over 2. And then x plus pi over 2 equals pi. So x equals pi over 2. All right, so if you want to do it using solving an equation mathematically, otherwise you just, as long as you know where the endpoints are of the parent, and then you know that you're just shifting it left. All right, so key point is going to be pi over 4. All right, so our asymptotes are where our endpoints are. So this is negative, which is normally where we would see, this would normally be the endpoints or the asymptotes for tangent. In this case, since we've just slid our parent over pi over 2, it looks like kind of at the same area. But, and it's cotangent. So now cotangent normally, right, normally cotangent would go, we're going to get 2 up, right? Cotangent would normally go here, here, and go from upper left to lower right. But because we have this reflection right here, we're going to start from at pi over 4, we're going to go up here to 2. And then negative pi over 2 come down here. All right? And now we draw this in. Now if you look at it, you go, wait, that looks just like tangent. And indeed it is. If you did, so negative 2 cotangent x plus pi over 2, that would be the same as just tangent x, well, 2, since that's that, right? So it's kind of interesting, maybe a little bit. Let's see, pi over 2, this would be the next one. Here, up 2, down 2. We can come over here, draw another one. Just if we're drawing multiple multiple periods. Okay. 1 period, 2 period, 3 periods, so on.